Hi, I'm Dave Robinson, and welcome to another screencast. I'll be using R and RStudio to analyze data I've never seen before. As usual, this data comes from the Tidy Tuesday project, an amazing weekly data project in R run by the R for Data Science online learning community. And as usual, I'm streaming this live, so if you're here, please feel free to comment, say hello, give ideas for new visualizations and analyses you're interested in, ask questions about the code I'm writing. I can't always respond to everyone, but I do read all the comments and I'm able to see them even as I'm coding. It's one of my favorite parts of doing this live. So let's get started. We have, let's see, yes, I was super slow in terms of getting the announcement up today. So thank you for being able to join. See, this I'm really aiming for kind of a, you know those clubs where you need to know, or those speakeasies where you need to know a password to get in. You have to like, hear the password from a friend and a friend. That's the vibe I guess I'm going for with these screencasts, where I only advertise them at the very last second. But yeah, let's get started today. So we've got U.S. post offices. All right. Certainly I can make maps. Maps can be interesting. I don't know, I haven't seen anything about this data yet, so let's open it up and let's pull it in. So it's from the Tidy Tuesday R, use tidy template. I like to do this to kick it off. I like to do library scales, theme set, theme light. Some of my favorite things to do when I kick it off, and load up the post office's data. I can pull up the help here, and I can pull up the post office's data. All right, I like that it's snake-cased, 166,000 observations. I wonder what GNIS stands for, something geographic. GNIS database. One sec, looking through that. I don't know what the GNIS database is, but it looks like it's like a geolocation data that has things like a county, a longitude, a latitude. Okay, that's cool. But first, what is this? It's what is it? One row for every post office. Punctuation has often been removed. Alternative names, the original name that was transcribed. I'm reading this a second. Spatial historical. Oh, okay. So year by year snapshot. Oh, this is really cool because I didn't realize when I first saw it. The idea is that it's a year-by-year snapshot of the national postal system, so we can see it. It's a fine-grained, expensive data set for studying the historical geography of the United States. Oh, this is really cool. We can actually see like the U.S. starting in a couple settlements and colonies, and then spreading out based on where did post offices have to be located. Okay, that sounds pretty cool. And I'm definitely going to be doing there's no question we'll be doing an animated map. All right, we have a lot of geography information, the year it was established, sometimes the year in which it reopened for 10 years or more, okay? Year in which it was discontinued, same thing here, where it can be where it stopped operating. Did it operate continuously between its established and discontinued dates? Okay, for post offices that closed and then reopened less than 10 years later, Hellbrook did not create a separate record, but uses field to note that it was operating continuously between established and discontinued date. Okay, one question here is, do I have something like a year column, or are these all separate post offices? I have a unique ID. Okay, this is the question. I don't know yet. Is this one row per post office per year, or am I going to be using those discontinued and continuous, those like established and discontinued columns to be inferring the years it was active? So what I'm going to do is count that ID column, sort equals true, and what I want to know is, nope, they are unique, so it's not multiple rows for each post office. I'm also really curious if I counted name. I bet there are a couple duplicates. Yeah, actually more than a few duplicates looks like. Because I've got my name, I've got my original name. But yeah, there's some that are Union Station, I guess, kind of is very Union Post Office is apparently very common. Fairview, etc. Okay, then but I also can say, if I wanted to look for unique ones, I could start by saying, okay, how many are there in each state? And you still and heck, if I add, I don't seem to have, do I have city? Well, I would have for GNIS, but let me try using sometimes multiple counties. Oh wow, this data, yeah, there's a lot. Unsurprisingly, there's kind of a lot going on with this data. I'm just trying to understand where the quality is, where any potential quality issues might be. Okay, so it's like if I'm looking at, for instance, the same state and county. Sometimes I have the same one in the same state and county, but presumably they're going to be unique. Maybe they could be more than 10 years apart. That could make a lot of sense if I look at this. Like maybe Acme, I'll take this example as actually like sometimes it's fun just to look at an individual example. Is Grand Traverse name equals Acme. Are there going to be two? They're going to be two. And if I try viewing it, yep, look at that. It was gone for 20 years. So I actually can look at this in a more systematic way. I can try doing add count to these and then arrange by name, original name, and state, and county one. I probably don't need all those columns. Just want to be as like clear as possible. These are clearly duplicates. Oh, if I filter then for add count adds an n column, so I can say n is greater than or equal to 2. I want to look at those duplicates. I just want to get like a feel for them. And yeah, so like here's two Ackerson ones. Yep, 98 to 99. And then see, this one does have like a quick gap between the two. This one, it doesn't feel like it's not a 10-year gap. But yeah, this one, you know, it doesn't. I don't see a 10-year gap. I see one with the same name. Huh. Presumably, there's a reason for it. Duration is number of years. It was, and then both those were so continuous. That seems a little odd. I'm just noting that because I can't always trust at least my interpretation of this data right off the bat. But it's definitely going to be like. So enough to really go on here. Here's what I'm going to do. I'm going to select the ones that I'm most excited about, the columns I'm most excited about. Why the ones I'm most excited about? Because I'm actually going to do some things with data that make it a lot bigger, and it's going to be easier to work with if I have fewer columns. I can always go back and get the other ones if I want. Okay, so let me see, county one. I'm going to keep just county one. I definitely want established, discontinued, continuous. What is a stamp index? This is an arbitrary field that says how rare a postmark was that originated from that post office. All right, I'm going to keep it. I don't know. Oh, yeah. And I definitely I always want an ID. And coordinates. Oh, was a post office successfully geolocated? I like that. Coordinates. Man, I'm going to keep most of these. GNIS, actually I'm just going to keep latitude, longitude, heck, I'm going to keep GNIS county and GNIS state just in case some of these are a little bit off. So longitude and latitude, then there's, well, let me check this now. Okay, that's good to know. It looks like there's basically, okay. So this is really cool. Who set up this data? This is really neat. Richard Helbrook and Cameron Blevins. This is really cool data because the story is when we didn't have a GNAS map for this, it tried to estimate the latitude and longitude based on like randomly distributed points in the surrounding county. Okay, so I'm going to hold on to that. I'm going to skip some of the other columns and. Heck, why don't I keep the quality ones? I'm going to skip some of the other ones. There's a lot more I can do with this in terms of quality. Oh, random chords flag does not seem to exist in this. Okay, it doesn't exist in the Tidy Tuesday version. That's okay. I'll keep this and I'll say post offices. All right, what do I want to do with the post offices? Well, actually, you know, I'm going to select it down even further. I'm going to say name, state, start and end. Why? Because I want to show what I'm doing here. Established, discontinued. The first thing I want to do is, what if I wanted one row for every year? Then what I actually do is I need a vector for every year that has every year from 1922 to 1932. The way to do that is a function called map2. So it'll be years is map to established, discontinued, seek. What that does, and it looks like, there's sometimes NA. Oh, I bet NA is their present today, so I can do discontinued, replace its NA with, let's say, 2021. Let me check on that. Does any of them arrange descending discontinued? Do they go back to 2021? So do they go all the way? Oh, some of these years are definitely not so good. Oh, no, but it looks like the latest year I have discontinued is 2002. I don't know if it has ones after that, but I'm gonna just say 2003, because we know at the very least we expect it wasn't discontinued in 2002. But the I'm also going to say, I'm going to put that in the filtering step. Filter discontinued. Actually, I'm not going to filter it. No, I'm going to filter it. Discontinued is less than or equal to 2002. Heck, I'll put 2020 just to be clear that, or 2021 just to be clear that I'm just removing the bad ones. Now, from must be a finite number. Okay. So I'm going to do filter not is NA established. So what this does is create a vector of, so this applies the seek function to every pair of established and discontinued. So now this gets 11 rows. I'm actually going to call this column year. And what's great about this is I can now unnest year and call this post office years. See, this is what I mentioned about being a little bit slow. This is going to be a huge data, 7.2 million rows. Not crazy to work with, but definitely large. And the that's why it's sometimes nice to have a fewer columns. Going to slightly speed it up. And the so why would I want it in this format? Well, what if I want to know how many post offices there are in each year? Not how many started each year, how many there are in each year. Now I can say n post offices, and I should get the number in each year. And now that I'm looking at it, some of these established are way too small. I'm going to say established is greater than or equal to, what did it say, 1639 seem like a valid year? I can check that in a sec, but 1639. See, there's always going to be a couple steps like this. And now if I rerun this step, and again, they go till 2003 if they're, and actually I'll already removing the ones that don't have an established date with this filter, so this is fine. So now I can say year n post offices. Geom. Well, let's make a bar plot. Oops. I thought that I'd gotten rid of. I thought I had discontinued. Hold on. I didn't want that. I wanted this and then filter, because discontinued NA is still meaningful, because some of them weren't. So I did not want that filter. Let me see. Replace NA discontinued, and now it says from must be a finite. Let me see this sec. I see what happened. This filter doesn't apply here. I needed this. I was just working with the wrong object. Now I'm still missing something. Established greater than or equal to 1639. I'm missing something. What am I missing? So if I do arrange by year, I've got a few that are discontinued less than so you know what I'm going to do? I'm going to throw another thing that says discontinued must be greater than or equal to established. Greater than or equal to, because you can imagine ones starting up and then closing in the same year. All right. So what this is showing, and I don't know if it's accurate, is that the number of post offices that are active, here we go, number of post offices has a peak at the year 1900 and has been going down since. That feels odd to me. That doesn't feel like, that feels unrealistic to me. I don't think that it actually is true that that the number of post offices has gone down to such a low value. I think that I'm doing some mistake here with my discontinued. Oh, here it is. I'm dropping, check this out. When I did discontinued greater than or equal to established, I forgot that some had missing values and the missing values are meaningful. I need to say is an A discontinued or discontinued greater than or equal to established. So that's a tough break. See, it was like, it had to go down to 0 at that point. Now it still has a drop. I don't know if it's real yet. We're going to explore it a little more, but it's definitely more plausible. Now notice that weird, like, I think the 1639 was just a little bit, I'm going to do a stat, it's just like, sure, I'm sure there are a few going back that far, but it's probably not that useful. I'm going to start with 1750. It's going to keep it a little bit better. Okay, it's still got a bit of a, 1750, yeah, 1750 is fine. It's still got a little bit of this weird pattern that's because it's got too many columns. There's a pretty easy way to fix this, which is filter only for even years. Try this. If I say, the trouble is I put too many bars, ggplot2 doesn't make it incredibly pretty. Actually, the easy way is to make it a line plot. No, even easier? Even better, geom area. We used geom area so much last week. Anyone here last week? Really here, this is not a bar plot anymore because it's like, it's so like continuous. So this is, here we are. All right, so we got a great fact check from the Data Digest. As of 2017, the USPS operates 30,825 post offices. So, oh, hey, we're actually really close there. In 2002, we're seeing about 29,000 post offices. I can quickly check that, arrange descending year. Yep. So the so we're seeing like 29,000. So it's possible that and compare that to 30,825 as of 2017. It's definitely possible that 14 years since there were 1,000 added, it curved up a tiny bit. It's also possible we're missing about 1,000, 1,500, but very reasonable. So it's really cool that it looks like there's a spike and then it decreases. But why did I make it an area plot? Why not just make it a line plot? Because I had something in mind, which is that I kept state for a reason. That is the state column. Let me see. Let's try to fix this up. All right. Yeah, what I can do actually is I can say count year and state, but there's going to be too many states in here. So I'm going to say FCT lump state top, I don't know, 6. And weight by, I don't need to weight by anything because the story is, I might want to actually say what are the most common state combinations of state and year, which is basically what 6 states make up the most area in this plot. Not necessarily the highest at any one point, but they have the most when you're integrating across this entire time period. That to me is fairly meaningful, at least meaningful enough that it is worth a visualization. I can now say fill equals state. Area plot's just great for this, and yeah, it's most of them are in the other category. The fact that most of them are the other category tells me I probably want a facet rather than an area. I will say, isn't it something that Kentucky is on top? Kentucky was not one of the first states that was a pretty early one, but it yeah, that's kind of interesting. And what I do for faceting is first I can make it. Let's make it 8. Still, of course, most of them are in other, but let's facet wrap by state. Now it definitely could be a line plot. Yeah, now I gotta drop the other. I think I'm gonna do 16 and drop the other. Yeah. Because the other just is so much bigger than everything else. And one more thing I'm going to do is order the states that I do. I'm going to drop the I'll say theme legend position equals none, and I'm going to say state is FCT reorder state by n function equals sum. I want to order it by the total area under them. Oops. Let me see, length of f is equal to length of f. Oh, I'm doing something wrong here. Let me see. Let me see. Dot fun. This. Oh shoot! I named it n post offices. I don't know why I did that. Fun equals sum. So sum. All right. I need to fix up how I use reorder. What I'm doing now is I want to make sure these are sorted. This is going to be sorted with the biggest one last. I don't think that's quite the way I wanted it. I'm going to throw a negative sign in front of that. Fast way to just get it with California at the top left. Cool. All right. So what this is then looking at is Pennsylvania is like in almost every state, at least these states that are at the top of them of the most post offices, you really do see this increase and this decrease in number of post offices since 1900. So it's not some kind of like geographical trend. Exceptions are California. Well, California was settled so heavily in the 20th century relative to previous years that it kind of makes sense that it less of a drop off because the population was growing so quickly since 1900. All right, so this is interesting. This is telling me I'm interested in a couple things. I'm definitely interested in an animated map. I'm interested in one with dots as a choropleth. What's a choropleth? That's a map where each region has a color by states. Yeah, I think this is going to be really interesting. It's like looking at the trends of a map, maybe comparing to population, post offices per person in state or in county. I wonder in the county, yeah, but per county, that sounds kind of interesting because if I can find that data. But yes, that either will bring in other information. So we'll see if we have time today to bring in the population over time data. All right, so so take a break for 1 second while we look at some of the. I'll take a look at the comments. So geographic names information system is a database that contains name and locative information about more than 2 million physical and cultural features in the United States. Makes sense. Good way to geocode these. Let's see I got a question from Barasa, which is why aren't we seeing the details of the data set as in the viewer? I'd recommend that is when I do when I type TT, I get all this detail in the viewer. Try upgrading our studio. That's the only thing I can think of. Upgrade our studio and reinstall the Tidy Tuesday R package. It's the only thing I can think of. My Stat 258 professor at U of T recommended your videos for a project. Oh, that's awesome. It's really exciting to hear. And the last question is Kentucky leads nation in closed post offices changes over time per state. I think that's a really cool idea. Is what if we look at, instead of looking at number of post offices per year, what if we said number of closures per decade? So if I look instead of at my original post offices data set and I group by, I've done this before where I say state and decade is, I remember how to do it, it's 10 times year discontinued. I'll say filter. What if I say 10 times discontinued over floor division 10 and I count? So this is the number of closures in each state per decade, as opposed to the number of active ones at any point. So the reason that could be interesting is, well, to start with just something like, look at one. This is Kentucky. I'm doing it by decade because I expect there to be fewer closures in any one decade than there are actively opening ones, though we will see. Yeah, wow, there really are some spikes here. Wow, so much so I really could have done it per year. Huh. Ain't that a thing? I'm going to keep it as decade because I think some of the other ones, wow, that really is remarkable. This is like, Yep, there in 1900, in the decade of 1900, 1,000 post offices were closed in in Kentucky. Hmm. I don't know what to do about that. I did not know. I don't know anything about post offices really. But let's create the same graph that I did earlier, where I'm going to do everything's the same except the count. And then decade. I'm not sure that aggregate by decade was the only. It's certainly not the only way we could have done this. Look at me making mistakes. What's going on? State is not equal to other. Oh, I wonder if. I still have. So first problem is I still have every state included in here. That's a mistake. If the oh, I never did the lump. Look at that. I never did this lump. And this is on post offices, not. There we go. This is on post offices, not the original one. Okay, so, and oh, I did not get rid of some. I've got some bad data there, some decade 20, the year 20,000 data there. So I'm going to need to do this same filter. I actually only need to do discontinued is in this range in this case, but yeah. I don't need to know the year it's established to know how many closed. What? So when and where were the most post offices closed? Yeah, other than that, this gets pretty close. So one thing is Pennsylvania has actually had more closures, it looks like, than Kentucky, but that's not looking at it as a rate of closure, which I also could look at. And actually, well, let's do that in a second. Is look at rate of closure, and the yeah, I like. Yeah, you know they're very comparable, so I'm in favor of keeping them on the same scale. There's absolutely no question that there's a giant spike in closures across many states in the year 1900. If somebody wants to look that up, that sounds like a story. Is just like in the decade of 1900, did a lot of post offices close, and what was causing that? If it had been something like the Great Depression, I would have maybe understood. Uh, but yeah, this is an interesting that's an interesting finding. Okay, the last thing I'm going to check before we start making maps is the rate of closure. So what I'm going to do for that is I actually want to save this as post offices open per year. And I'll call this cumulative. This is cumulative, not started per year. Actually going to call it post offices cumulative. See, there's a little bit of logic that has to go into this because we're like, sometimes I'm looking at every year it's open, sometimes I'm looking only at the years that it finishes. That's probably the hardest part so far today. And here I'm going to save this as post offices, post office closures. And looking at this, I want these to be on a comparable scale. So I'm going to leave in, well, no, any that are not open don't matter, but I'm going to leave in this filter on the closures because I don't want to include any in one data set that aren't in the other. So that was like a slightly detailed thing. Now I'll say post office cumulative. This is how many there were in each year. And now I'm going to join that. Oh, I'm going to leave this. I'm going to leave this table where it is. I'm going to do something different here. I'm going to say post office closures, and I'm going to interjoin that with post office cumulative by state, and by decade equals year, we'll say here's based on how many were open at the start of the decade, how many end up closing. So that's not actually a perfect measure because it some can open and close in the same decade. I'm just gonna leave it as this because I think it's probably not gonna be that far. But let's start by saying PCT closed is n closures divided by n post offices. And see, these are examples. There are 2 closures despite the decade starting only with 1. I'm going to actually just say n closures if you don't have at least, I meant to say if you don't have at least 20 post offices, don't even pay attention to you. Heck, let's make it 50. If you don't have 50 post offices at the start of the decade, let's not consider it. Okay, so like an example is in Georgia, there were 7 closures out of 53 in one decade and then 88 out of 65 in another. Yeah, looking at it, I really need to. I really do wonder. But let's take a look then at let's just look at Kentucky and Pennsylvania. What if I say KY and PA, Kentucky and Pennsylvania, and I just look at decade, PCT closed, geom line, color equals state. I just want to compare like the rate of closure. Expand limits y is 0. I think actually it already hits 0. And I've got to really do filter decade is less than 2000. That's a incomplete decade, and say labels is percentage of post offices. This is not, yeah, okay. This is actually an imprecise metric. We can get it a little better because of the fact that some can open and close in each decade. But the general story is that Kentucky had a very high rate of closure relative to how many post offices were there, but that it's been going down over time, and Pennsylvania kind of kept up. Man, I do not know what was up with Kentucky. We just had all these post offices, just opened tons of post offices in Kentucky, and then closed. Yeah, I don't know. All right, and then like way too many post offices, and they had to close a lot of them. Huh, interesting. So Pennsylvania might have had more closures aggregate. We saw that, but it's not a higher rate of closures. All right, we could look at that some more, but I'm really interested in doing some maps. So let's go ahead to the maps for the second half of our screencast. All right. So So let's start with the simple choropleth. I think I'm just thinking about this for a second. I'm going to do one on just 1 year. So I've got my post office years, right? And now I can filter for year is 2003. Let's do 2002. We know that one's complete, though they're basically the same data set. No, actually, no. 2003 will be all the ones that I know weren't discontinued in 2002. So sure, this is our most recent bit of data. So I can start just by saying let's create a map of post offices, of numbered post offices by state. Why not? It's not going to be that informative because it is going to it's going to be heavily confounded by population. But let's throw it in here. So state count state. Sort is true. Hey, so California is the most populous state, but it's not at the top. Pennsylvania has more post offices than California does. All right, so that's one interesting thing. But I'm going to want to make a map out of this. You've seen me do maps before, so usually what I do is map data, and I'm remembering what is it called? State, it's called, and make it a tibble. And we get this like region and subregion. The real challenge here is that region, notice, doesn't have a it doesn't have a code, but luckily R actually comes with, this is crazy, but it actually comes with state.abbreviation and state.name. So I actually can get one from the other. The way that I go about doing that, there are a few ways, but I'm gonna just create, let's see. Notice that these are uppercase. It doesn't matter. What I'll do is I'll say, check this out. It's going to be state abbreviation. State. I'm going to say state is state ab. Watch this. Match state. Match region to string to lower state name. Match will line up the indices of each of these values with something in the state vector. So it'll say, oh, Alabama, that matches to 1, which then indexes out to state. This is a non-tidyverse trick. I could have done this with a join. This is a fast way. I'm going to count state sort equals true, and look at that. This is not a real data, and this is just hey, what missing data did I have? Filter is in a state. What didn't match? District of Columbia didn't match. What was it called here? Is just nope. District of Columbia is not in my set of state names. So heck, I'll just what is it? What is it? It's probably DC or something. I wonder, is that in our data? It is in our data. Yep, it's only 1. Huh. So I'll just do, why not? I'll do replace in a state is DC. So check that out. I was able to say, here's our map, longitude and latitude for our state. So state map, states map. I can use this wherever I like because I can always take any table, join it in. States map. And check it out. Now I've got now I'm matching my state to all this data, and it's got its N right here, number of post offices. What I love about that is now I can do, I usually like, what do I like? I like to do GG themes. And I like to do long, lat, geom, polygon. I forgot to do group equals group, fill equals N, geom polygon, theme map. And I've got a map of the United States. So this would say, okay, lighter blue would represent states with a lot of post offices. You know, this map is fine. I could make the color look somewhat different. I could, for instance, use a gradient where I would say scale fill gradient. I like scale fill gradient 2 and say low is red, high is blue. Oh, and I'd have to say midpoint is 1,000 or something like that. That actually, now that I think of it, I should probably flip the order. Blue means not a lot of and midpoint should really be like 750 or something, right around the middle of that scale. So you could say like, okay, what states have a lot of red means they have a lot of post offices. Fill is number of post offices. This is the first attempt at what we call a choropleth, the colored map. It's honestly not amazing. Why is it not amazing? Because, as I said before, it is overly focused on population. So we can say, okay, Pennsylvania, New York, Texas, and California. What do those states have in common? They are some of the most populated states. So I have to do some kind of like and a lot of states out here that have fewer post offices, as well as something like New England and such. Yeah, they don't. They definitely it just makes sense. I'm not learning that much from this graph. What I might be interested in is normalizing my population. So let me quickly say state population. I still don't remember how to do this. Here we go. US. Oh, this is neat. What is as of 1975? Oh my goodness. Whatever. You know what? I'm gonna go with it. It's built into R as a set of instead of like 1975 statistics. You know what? Why not? The reason I like this is that it actually is in the exact same order as that earlier data, where I can say population is what, in thousands? It's gotta be. No, I'm not gonna do this. What am I doing? Here we go. Ooh, US history data. I haven't heard of this package. Is it on CRAN? Yes. Ooh. I'm excited. I just Googled like history, like US state population, and here we go. We have census. We have this. We can just look at the 2000 numbers. It'll be real close because I'm looking at 2003 here, and that should get us real close. I'm not going to use a silly built-in data set. What am I doing? Let's see, library history data. And what's the data set called? US state populations. I love this, and it's a tibble and everything. All done by ROpenSci, really helpful of them. 2000, and I've got my state name here, but I need to do I would need to match this to a code. So let's do the same thing. We have a very similar thing we have above. I don't think I need the string to lower, and I do need this Great, not at all 51 states. Okay, states, they pop 2000. I'm going to keep the 2000, but I'm probably going to use it for more. And yeah, what's great about that is now I can do an inner join. I'm going to keep this table. This is not a bad table, just bad graph. I'm going to say, heck, I'm going to filter for 2000 to make it directly comparable. And now inner join by state, pop 2000 by state. Still up, great, I got the data. Oh hey, I have GIS data. I could have joined on GIS because we have the GIS state. That's okay, we've got this worked out. And now I'll throw in post office density is n divided by population. You know, this is going to be, the number is going to be so small, it's probably better to do number per 1,000 or per million. So that'll be, let's do post offices per million. Sure. Yeah, okay. I think post office per million is a solid way to do this. And now I'll say join it with the states map. Yeah, density of post offices per million people. How to say density? And nope, I didn't change the fill, and I didn't change the midpoint. Here we go. Let me make that midpoint a little closer to the middle. Sure. Let's take a minute to look at this. Okay, this tells a different story where it's like, which one of these is Wyoming? My geography is dreadful. Somewhere in here is Wyoming, and Wyoming doesn't have a lot of people, but it sounds like it has plenty of post offices. So here we actually can get a sense that probably, if anything, the bigger states have a lower density of post offices, which does make some sense to me. Like cities can one post office in a city can have a lot more, like a very crowded city can handle a lot more people. Then, oh, those are the Dakotas. Thank you. Oof, I'm bad at Midwest geography. So thanks, Jonathan. And here's North and South Dakota. Somewhere in here is Wyoming. And the what we're seeing is where like the hot spots of high post office density. Maine and Vermont. Is this West Virginia? I think this is West Virginia. You actually can see that Pennsylvania, out of like these larger states, Pennsylvania is like a lighter blue. That is, we saw that, yes, it has a higher post office density than, say, New York, Florida, Texas, or California, larger states that have fewer post offices. So that's one thing we would learn from this. So this is a density plot. Okay, that's useful because I'm going to want to do a choropleth over time. And once I want to do it over time, I'm going to change this to state pop. Rename this. I'm going to make the join here to have the filter baked in. Why am I doing that? Because I'm so close to being able to say, remember I have that table called post office cumulative. I have post office cumulative, I have the, and I can say inner join this with state pops by year and state. Oops, if I do this, I've got to get rid of the other column. You know what? I'm going to recreate this because I really don't want that other, I don't want that other column in here. So I'm going to call it, I'm going to call this post office cumulative all or something. Nope, I meant to do all. And now do I have 51 states? Yes, I checked. I just want to make sure they all got through. Okay, so now I've got the year. Now it's only going to be every 10 years, not going to be every single year. But now I've got the year and I've got the density of every one of these states. And that's kind of cool because I can actually say, let's say I only want to look at a couple of years. Let's say I want to say filter for year in, I don't know, let's say 1800, 1850, 1900, 1950. Let's start with that. And oh yeah, a lot of these states are going to be missing because maybe a lot of them don't have any or at least don't have any post office data in 1800. That makes sense. What I'm going to do is I'm going to take this, I'm going to right join it with our map data. and I make the map from there. Oh, first I'll say density is, I've already got that line, post office density. And I'm also going to do filter for population must be greater than 10,000, otherwise it's going to be too tiny. One sec, I'm missing my join. Yep, okay, I need to do right join with my states map by state. I'm going to drop this filter for a sec. Okay, and my N is now called N post offices. No, I'm doing that. And I'll do, okay, now I actually have, for these 4 years, I have the density at each state if that state existed at the time. And now I can redo that map plot but facet this time. I can do nope, I didn't facet. I forgot to facet. Why am I giggling? Because everything started right around the mid. Well, post offices by million people. My scale is no good here. And does that make any sense? Yeah, it probably does because I calibrated this completely differently. Let's try this. Okay, the story that this is kind of telling, man, density is going to be tough here. Let me start without doing density because otherwise I'm looking at population. It's a whole situation. So what if I'm just looking at N post offices? I did a right join. Why did? I thought I did a right join. I thought that was. Oh, I know what happened. Yeah, the right join. Now the year is going to be missing on any that have a right join on the states map. So that's why I don't have like outlines of states that don't exist. Honestly, I actually kind of like this. This works for me anyway. I'll just make it another join. But yeah, the year fast I think was throwing that off. All right, so what this is showing, let's see. Let me make, yeah, let's keep that scale fill and its number of post offices, and let's make 3,000. Let's make 2,000 the midpoint. I don't know. I'm kind of just playing around with this. All right. Aha, so now we're actually able to tell a story. I haven't done this yet. Yes, the this graphic, we're going to turn this into animation, but the idea is like, where do we have post offices? Well, in 1800 only is many of the original colonies, and then a couple other states like Tennessee, and then in 1850 we see some in California. Then in and actually not even a few in California, like maybe a lot based on the blue. Oh, but the blue is, no, I take that back. The blue is pretty deep, and that means very few. See, that's a problem with having this white be in the middle. The way we can change that is say mid equals pink. Is this going to look any good? It's going to look like not perfect. It's not going to look fantastic. It works. So what this is looking at is like, okay, 1800, 1850, we're seeing the map fill out. Now let's, now that I do that, I don't actually need to, well, I'm going to do this by year. You know what I'm going to do? I'm going to left join, and now I have by state year, and now I have, drop this, by state year. Now I have this table. I just wanted to get like a table of this format, and it's going to be missing the extra data for all the years, like the density and the population for any year that's not factor of 10. That's because it doesn't have those census years. That's fine. We only need that for some graphs. I just want to do filter. Now this is one graph we made is 1800, 1850, 1900, 1950. Okay, let's make our animated choropleth now that doesn't necessarily limit it to 1 year. I'm going to start with year mod 10 equals 0 because it's good to start with a limited one. And I'm going to take this same visualization, but instead of facet wrap by year, I'm going to library ggAnimate, and then I'm going to, not facet by year, but transition manual by year. Transition manual means it's going to render one frame for each year. Just realized I forgot to show what year it is. But you know, it's already looking like kind of neat. I'm going to make it every 5 years instead. Heck, I'm going to make it every 4 years. It's going to be a little bit slower, but I'm just going to run that for like every 4 years. And I'm going to add something here. I'm going to say, for the next iteration, I'm going to say title is, shoot, is it, so remember, I think it's current frame. I think it's this. But before I run that, I'm going to quickly confirm. Yep, but this is our animation where we'd say like, that's pretty nifty. So what I do is I like to run it really low. There's my title. It's not amazing, but there's my title. So now I'm going to go back to every 4 years. This will take a second to render. It's making each of these. Plots. So I got a great question from Leo, which is: would dplyr complete? I think it's tidyr complete actually help to make the maps the same shape? Yes, I can show how that works. I actually like that the map completes slowly. Honestly, to me, it like feels like, oh yes, the map is filling out. This is nifty. Watch this. Oh, watch this thing. It's like yeah, look at it. No, oh, hold on. Yeah, it didn't finish that time. 70s, 2000. Yeah, I'm gonna go ahead and try running on. Let's run on every year, see how it does. That's probably gonna be too much, but let's see. It's gonna take a while. Yeah, I kind of like how it builds out. Yeah, so we could have now. One thing is, remember, we could have just done this with population. So it probably would have been a somewhat similar map, but I love how Pennsylvania gets so red right there, and then and you notice it kind of sinks back down. So that's something that you wouldn't see with population, is that the number of post offices gets really red for a little bit and then it sinks back down, which is similar to what we saw before. So yeah, here's where all these post offices are getting built. Man, it's doing 200 something frames. It's taken a second because it has to do that one of those graphs like 200 something times. So let's see give it a second and we'll render this choropleth. After this choropleth, I'm probably going to try one with dots, where we show the locations of the post offices, which is what we call a transition reveal. I think it's transition reveal, but I'm going to have to think about how that. Going to have to think for a second. Oh, you know what? I can use my post office one. It's not going to be that hard. Okay, so watch this. Yep. Oh man, that's a continuous one. That looks smooth. How do I save that? What do I do? Anim save. That's the one. Yeah, I'm going to do anim save desktop post. I always put everything over time. Let's do it. Yeah, that was really fast. It already had the GIF generated. That's a neat choropleth. Yeah. I wonder if 5,000. I wonder if it was a better on a log scale. No, I like it on this scale. All right. So this is this is how they built that. All right. And the other one I'm going to look at is I've got my post office cumulative all table. What a great name. Which has 10, oh no, I don't want post office cumulative all. I actually want the data set that early on I created, which is post office years. So stories, I can pick one of these years, and I can say year is 2000, and I can ask where are post offices right now. Geom point, and I'll just say, if I do this, I've got to keep post office years to keep latitude and longitude, which it doesn't yet. I'll say so here's 29,000 post op. We already saw 29,000 in the year 2000, and if I do latitude by longitude, Here's, oh, look at me, forgetting which word goes which. I've been doing it right the rest of the day. But yeah, I think I'm going to do continental United States. Sorry, do I have any viewers in Alaska or Hawaii? Sorry, but I'm going to do state, not state in HI, or I think it's AK. Alaska? Did I get that right? Yep, so continental United States. Okay, so that's extremely crowded, which means I'm actually going to try a smaller point size. I can't remember the default point size, so I'm going to guess around. It's a little bit smaller. Let me make it even smaller than that. I can get even smaller than that. That is kind of, now we still can't like distinguish here. Here are the post offices in each state or anything like that. Heck, how small can points get? I really don't know much about this. I don't know if those points got any smaller. But yeah, if I can do theme set, oh sorry, not theme set, theme map and coord map. I can't do that on the world map. I can do that on this here. This looks a little more like the U.S. that we're accustomed to. So I'm throwing this in as a map without state borders. I can really easily add borders. There's a great thing called borders state, and put it under the points. And that's like a ggplot2 layer that adds these state borders. I'm gonna leave them in. I'm gonna leave them in so we can see the states, but it's worth noting that it'd still be a cool graph. This would still be a cool graph, even though I don't have this. What if I did the year 1900? There actually would be even more post offices that year than there were in 2000. Remember, so this is wow. It just gets really dense at that point. So I'm gonna make this another animation. I'm gonna say year mod. So mod 10 is 0. Okay, and then I'm going to do transition manual year. I got this. I don't need any fill. What if I did every 20 years just to like be fast with it? And I'm trying out saying like make a geom point for every 20 years. Let's see how it looks. Oh ho! Look at it! Look at us spreading. Ugh! I like this way more than the core plot. It's kind of spooky, isn't it? And you see it then thin out. So that's really interesting. It's not probably gonna have. This is not gonna be a very fast map to render because it's got these literally millions of points it's gonna have to render. So that's why I'm not doing every year that you absolutely could. And I'm gonna try watching it spread. This is it's a nifty graph because you've seen animations like the one I like is I saw this one that was nuclear explosions per year over time. So you start by seeing, I can't remember where I saw it. You start by seeing these two during World War II, and then more tests, and then more countries, and then nuclear test bans in the 90s caused that to slow down. I thought that was a cool graph. I've also remember seeing one that was supposed to be one for every. It was something like one for every million people over the last 2,000 years or something like that. But yeah, this is post offices, and yeah, wow, watch it spread. It's kind of, what's interesting about it, it's not really the spread of people, it's kind of the spread of like what you kind of call civilization. If anyone seen the show Deadwood, it's about a town, how like a frontier town becomes part of the U.S. and how institutions like that build. Oh, sorry, I'm being distracting. Check that out. Oh wow, watch these grow. Ooh, I saw a great idea, which is what if we add alpha? What if we add an alpha? What's stroke equals 0? Let me see this a second. If I do. I'm gonna just go just like 2 or 3 minutes over. If I say year is 2000, don't animate, and if I do, so this was my original one. One sec. This was my year 2001, and an idea from Leo is what if I make them transparent? Yeah, I think that's my opinion. That's too transparent, but it does show where the higher density is. What does stroke equals 0 do? That's probably not what I want. But yeah, I'm gonna use alpha. Let me see, 0.25. What would this look like in the year 1850? That's really cool. Okay, that's kind of cool. All right, I'm going to do one more graph with this. And I'll go for all the marbles and go every 2 years. This is going to take a second to build. So with this, let me see. Yeah, now that I'm looking at it, it's like I was thinking of we could do a county level core plot. I like this a lot more. What do I like about this? Well, one thing I like is it's like California became light blue in 1 year, but like what does it mean to go from white to light blue? It means like you build a few little post offices, few little post offices here, few little post offices there. This really gets across kind of the spread of the U.S. population and of the like the postal system. You even can see things like I actually did not expect there to be such a and it makes sense now that I think about it, to be such a clear frontier. Is take a look at this. It's like of course people don't in the year 1800. This is 1800 I graphed. No, this is 1850. People I guess in 1850 there already was a Texas, but I think it was in the 1840s that it's war of the Mexican-American War. But it's such a clear frontier. It's like yeah, people don't. That's why the core plot doesn't capture this. That people don't like settle a state. They settle further and further out. And you can kind of see this. Okay, here's how far it went. Here's even how far it went up into. This is Michigan. I'm dreadful. Yeah, this is Michigan, right? Great. It's like it just stops at one part of Michigan. Oh, look at this giant gap in upstate New York. And if you ask someone like me who lives in Manhattan, that gap never got filled in with anything worth visiting. Oof, look at me being mean. But yeah, you can see like these holes of like low population and then in turn low settlement with post offices. Let's look at this. All right. Oh wow. And then it thins out. Ah, this is my favorite one. This is a cool one. I don't know what everyone else is just like. Does it give you the shiver a bit? Yeah, I don't know. This is definitely the one to end on. All right. So what do we do today? Well, I'm gonna save this one so I don't forget. It's what is it? It's post office dots. Okay. So what do we do today? We did a little bit of data inspection and cleaning, and the most important thing we did when we did this is realize that this is one row per post office with a year started and a year discontinued. So that meant that if we want to look at something like post office over time, we would need to expand the data out using this map to an unnest approach to get a data set of one post office per year, one row per post office per year. Once we did that, it was easy to start doing geom areas. And the what did I do? Oh, I did that's what happened. Yeah, I was able to start doing geom areas. Once I did that, I was able to start looking at things like geom area by state. And realized that would best on a facet, and saw that there's a very similar trend across all these states of growth, and then decline. But it really occurred to us that we wanted to look at something. We also looked at closed and when and where post offices closed. We even looked at the rate of closure, which is maybe more meaningful than looking at the total number of closed. Like Kentucky, Pennsylvania might have had more closed, but Kentucky closed a larger percentage of their post offices. But then we brought in the maps. And we started with the simplest one, which was something like a number of post offices. And we said, oh, maybe we really want to look at that as a density, because otherwise you have like Texas and everything leading it up. And we say, okay, density is actually higher in some of the smaller states, especially in the Midwest and in New England. West Virginia, high density too, just post offices per person. But once we really looked at then we looked at a core plot. We did an animated core plot. I'm not going to rerun it because I really like the dots a lot more than the core plot now that I've seen them both. So we experimented with 1 year of a core plot. We did 2000, and I can do 1850. We can look at the peak year of 1900. And then we decide, but after trying a few of these, we experimented around and decided to look at an animation. And can I pop it back up? What was that animation? Nope, it's not. It's not going to. But hey, can I open up the? If I did post office thoughts. Where does that open? Ugh, oh, I don't have a GIF. I don't have a GIF viewer. Whatever. I'm not able to pull it up, but you all saw it. It was great, and I'm not able to pull it back up from memory. But I'll run it while I'm finishing up because I think this was a really cool. Oh, somebody said yes. People are telling me it's in the viewer. Yes, thank you. That's great. I'm running the full one while we're at it anyway. But yes, thank you. All right. So that's it. And yeah, one thing I'm seeing seeing suggestions from Andrea and from Nick that this will make a good data is beautiful poster posted on a. I totally agree. I think this is a nifty graph. Any thoughts on I'm thinking about how I can make it maybe a little more polished. One is I'm going to make the borders a little thinner. Right now, it takes up a lot of the map. I'm probably going to increase the resolution. You can control this with some of the settings in GGAnimate. It's going to be this would be too big a GIF. I suspect with this many frames in it. I also want the other thing to do is slow it down. I actually think it's worth appreciating a little bit how it's changing. And that can be set with your, there's some options to GGAnimate. One of them is how long the total GIF takes. All right, that's it for today. Like I said, keep an eye on I'll tweet this, and I really do like it. I'm going to post it places. Yeah, thanks so much for joining. If you enjoyed today, please do like and subscribe to the video. Hope you had fun. I certainly did. I'll see you next week.